Write the inverse relation of each of the following functions. For each part of the example, sketch both the function and inverse function. Add the line y equals x to your graph. Try to use equal scales. We're just going to have to wing that a bit because I haven't provided actual scales. What do you notice? The first one is f of x is 1 minus 3x. So let's follow the procedure that I outlined above. First of all, replace f of x with y. We then interchange x and y. So x is equal to 1 minus 3y. And rearrange to make y the subject. So 3y is equal to 1 minus x. Y is equal to 1 minus x on 3, which you might write as 1/3 take away 1/3 x. So let's think about those sketches. So the original function 1 minus 3x is going to have an intercept here at 1, and the gradient is going to be -3. So that line is going to look something like that. That's our y equals f of x. Now, let's put on the line y equals x on here. So it's going to look something like that. We can't get it really accurate without the actual scales. And then let's think about our inverse function, which we've said is 1 minus x on 3. So the y-intercept there would be 1/3. And if the gradient is -1/3, the x-intercept would be at 1. They must actually cross, so I've probably got that point a little bit wrong there. They must actually cross on y equals x, since it's going to be a reflection. And that line is going to look like that. So, probably doesn't look quite as good as it should, but this limb of the inverse function, should label it, is a reflection of this bit. If you look at the position with respect to the x-axis and the y-axis there, and then this limb here is this one reflected. So if you do that more accurately with something like Desmos and try and make the scales equal, you will see it better than that. I think the next examples might actually be a bit better. So the next one is f of x is x cubed plus 3. So we're going to let y be equal to x cubed plus 3. And then interchange x and y. So x is y cubed plus 3. Make y the subject. So y cubed is equal to x minus 3. Y is going to be the cube root of x minus 3. And that means the inverse function is the cube root of x minus 3. Well, x cubed plus 3. What does that look like? Well, we know what x cubed looks like. It's going to go something like this. So that's our original f of x. And then we're going to put the line y equals x on here. I wanted to use a different colour. So there we go. That one is y equals x. And then let's think about x cubed take away 3. So if we have that x is equal to 3, y would be 0. So that's that, and that's the reflection of that point there. As you can see, they must cross actually on y equals x if it's a reflection. And so that one is going to do something like this and this. And that definitely looks more like a reflection. I've not spent a lot of time to try and make it look exactly like. Again, plot it on Desmos, see what you see. And then we've got f of x is equal to 10 to the power 2x. Now hopefully you've done some logarithms, because we're going to need logs here. So y is equal to 10 to the power 2x. Interchange x and y. So x is equal to 10 to the 2y. Then what we're going to need is log to the base x would be log to the base 10 of 10 to the 2y. Log to the base 10, sometimes you'll see the base written here, but if you just see log, that does mean log to the base 10. And log to the base 10 and 10 to the power of, those are inverse functions. And so the right hand side just becomes 2y. So eventually what you're doing there is with the 2y as an input, you're putting it into the 10 to the power of function, getting 10 to the 2y out, and then you're putting it through the inverse function, which is y, you're going to get 2y back. So we've got log to the base 10 of x, and then y is going to be half log to the base 10 of x, and so we can say our inverse function is a half log to the base 10 of x, which you can simplify further using a log law. Now 10 to the 2x, that is an exponential function. So that is going to do something of that nature. Then put on y equals x. So that first one was y equals f of x. And what you will find is that the half log to the base 10x looks something like that. And so it is a reflection. But I know I drew it as a reflection, so therefore it should look like one. But if you try it on Desmos or on your calculator, try to use equal aspect on your calculator, you'll see that it does look like that.